grid size, right? The grid would be specifically with the grid will be able to tell you how many Reed-Sternberger cells there are in each cell. Okay, so for example, if you have a 10 by 10 grid, probably you can say that in cell number 2 there are 4 Reed-Sternberger cells, and in cell number 98 there are 4 Reed-Sternberger cells, something like that, right?
Yes, right.
Right. So this is an easy thing to do if I understand. It's not a big problem, right? Are you there, Akshat?
Yeah. I mean, yeah.
That's
We already
that's
had the code for making WSI into
exactly
patches.
right. So basically exactly the patches, right? But what I would like you to also get more information from this one is that you basically do patches, which that information we definitely have, and then we identify in each patch how many Reed-Sternberger cells are there from the CD30 image. Okay.
Okay.
That is first, and then hopefully you can also reconstruct that patch, reconstruct the entire image based on the patches.
That I okay. Okay. Got it.
You
Got it.
basically stitch it together,
So,
right?
Yeah. Okay.
sorry,
Okay.
Kshitij, sorry, I just joined, and you can present in case you want.
Okay. Akshat, can you share your screen now that
Yes.
Professor
Yes. I
Ganesh has
can.
given? Yeah.
Yes. Yes. I can. Just a second. Screen. Uh, yeah. So one was this WSI,
So
and the other was this one.
yeah. So this is not HNE. This is the actual, right? Subhash?
So the one which is gray is the IHC, and the one that this is the immunohistochemistry. So I think this is for CD30, right?
CD30. Yeah.
This
Yeah.
is CD30 and this is HNE, right?
Yes.
Yeah.
Correct.
Yeah. So you will have to first flip it, the HNE thing, you will have to flip it on the vertical axis so that it is
Matching
more or less
the
overlapping.
Yes.
yeah.
Yes.
Okay. So that you will have to do. That is the first
Yeah.
thing that you will have to do.
Okay.
The second thing is once you go through those patches of the CD30 image, so basically what we were talking about just now, right?
Yes.
Yeah, this
CD30.
one. Yeah. For example, if you go through, you basically parse through this image and make particular patches so that you can just identify CD30 cells which are brown in color, because the CD30 cells will be brown in color.
Correct. So the cells will be large, and the nucleus will not take up the stain, but the cytoplasm will take up the stain.
So could you give
So
an
not,
example here,
that's what I'm saying.
Subhash?
That this is not. Actually, this is not.
Okay.
So
Okay.
there'll be some more example where you can identify the nucleus. So you can see the nucleus in this image. All
This
are
one.
negatives. You can make out any nucleus you take.
Okay.
Yeah. So these are
Right.
blue nuclei. So your
Yeah.
CD30 will also have similar nuclei, but the cytoplasm will be brown. So if you zoom somewhere else, some other location, if you can show me some other focus where you can identify brown color. This we have given you the image.
Yes.
Yeah. So there must be.
There is brown here, but
No, not that.
No, not that one. It should be a good cytoplasmic brown color.
This one.
Yeah,
This one.
that
This one. Left side. Left side.
This
Left
one?
side. Yes.
Yeah, zoom it out. Zoom in. Yeah,
This
somewhat
one.
like this. The large cell with a brown in the periphery. Then maybe some
Okay.
more. Let me see what number is this.
Can you zoom out?
Yeah.
Zoom out. Yeah.
So
So
this is
you
one.
have something at 5 o'clock.
Yeah, come down now. Come down here. 5-6 o'clock. See there is. Yeah. Zoom in here.
Zoom in there. More.
Yeah, see there is.
So
A bit
this.
more. bit
Yeah,
more, a
yeah,
bit
yeah, I
more.
think these all cells.
Yeah, this is the Reed-Sternberger cell. Yes.
Yeah, correct.
Okay.
And see the up also. Like if you go little up, move your cursor up. हाँ अभी वो center में जो नहीं zoom. Yeah, so you see the nuclei is negative and it is around, the brown is around the upper one. Go little up. Just move the cursor, don't move the screen.
Okay.
Go
नीचे आ
down.
जाओ. Go
Go
down,
down.
go down, down. Two
Left,
brown
left.
dots.
That's it.
That,
That's it.
yeah. See, now zoom that one, the upper one.
Go. Yeah, that's
Yes,
one.
yes. See the nucleus is still blue, but it is around the nucleus.
Yeah, right.
Yeah, understood? So it will always be a cytoplasm or a cytoplasmic membrane type. The nucleus should be negative. And even the one at the right side, the only cell on the right side, say at 3 o'clock.
This one.
Yeah. If you zoom this, see the inside is still blue and it is
Yes,
everywhere up. Yeah. So this is a RS cell. And see if you can match the size compared to the adjacent cell, this is quite big.
Okay.
So this is
makes sense.
the size is 1. And on IHC, it is the cytoplasmic brown color or the cytoplasmic staining which it takes.
Okay. So, Akshit, did you understand what I requested you to do?
Yes.
So
Basically, we have
basically,
to make
yeah.
patches and identify the RS cells in those patches.
Yes. And actually, we have this written already. If you talk to Raja, actually, he has done it already.
Okay.
So I can.
Why did Raja not join?
I don't know actually.
So these are not RS cells. If the nucleus is brown, then it's not an RS cell, right?
Subhash?
Yeah, so I'm saying let's not use these ones because it will then affect our results. Because I'm not
Okay.
sure in this image, at least I'm not sure. I can see the top one, which is at 11 o'clock, is an RS cell because it is in the cytoplasm. Yeah, the nuclei I can see negative, and around it is positive. Yeah, see this? The center is negative. Both the cells, in fact, the upper one and the lower one, both.
Okay. These are
Yeah,
this. Okay.
the nucleus is negative, so it may be complete cytoplasmic. Sometimes it may concentrate at one end, and the other part will be little slightly light brown. But it has to be in the cytoplasmic zone. So what we see, if you see the upper two images, there is little dark brown at one end, concentrated, and the rest part is light brown. So there is that CD30 concentration in the Golgi zone and in the cytoplasm. So all that we consider as positive. So it can be diffuse, it can be focal brown, but it has to be in the cytoplasm, not in the nucleus.
Is it clear, Akshit?
Yes, sir. Yes, sir. But
So right now, sorry,
we
yes, go on.
were gonna overlap these two, right?
Yes. So that would be
So
the second objective, right? Afterwards.
okay.
First, you have to find the Reed-Sternberger cells in this particular image.
Okay. So would we still be using the data programming approach to identify the RS
I
cells
think
or
so. I think so. Yes.
okay.
That's an
Okay, then.
RS cell where your pointer is.
That's an RS cell.
Yeah. Exactly this one.
Yeah.
Yeah.
No, and it is big also, right? It's the size is also bigger than the others.
You can see the nucleola also, which is not stained, which is inside the nucleus. Yeah. So these all cells we have to target and capture this data, the large cells with cytoplasmic staining.
So Akshit, actually, this becomes the first task.
Yeah, okay.
Then let's worry about overlapping later, right? So this by itself becomes the
Okay.
first task. Yeah.
Okay.
And
I thought that we were using overlapping to identify the RS cells. That's why I asked.
No. So first we identify this, then we actually overlap this with the image that you have on the right side, which is actually flipped in some way, right?
Yes.
So
Right.
you overlap it. There will be an approximate overlap, but it will still be an overlap. But then
Yes, right.
from that right side image, the flipped image, you delete delete any information that you are getting in the location of the RS cells that you have identified from the first image. Okay. And then we do unsupervised clustering on this new image that we have. Did you get what I said?
Yes, sir. Got it. Got it.
So can you repeat it?
So basically, first we identify the RS cells in the CD31, and
Yeah.
then we overlap the images and remove the RS cells,
Yes.
roughly remove the RS cells from that area,
Right.
and then use clustering to identify the environments that are
Yes.
surrounding the
So
RS cells so that we can
now what will
get
happen, you know,
pointers.
once you delete the RS cells from the HNE cells, HNE staining, right, on the right side, you have only the microenvironment information now, right? Right? You
Yes,
only have
yes.
the microenvironment information, and we have to find whether we can identify subtypes of microenvironment from this.
Yes, right. Got it.
Got it? So
Yes,
I
right.
think the task is cut out for you now, right?
Yeah. Okay.
Okay. Professor Ganesh, you're there?
Also, we should keep in mind if we can instantiate multiple such labeling functions.
Yes.
What would be these? That's because that's when the consensus starts mattering, right?
Yeah.
So
The
how?
size will be one, right, Professor Ganesh?
Mhm.
The size will be one. The binucleated nucleus will be another. And the third would be the color of the brown colored cytoplasm.
Yeah, but even that should be a class. Each should be a class of labeling functions. I mean, the color, for example, right? The color there's a spectrum. There's
Right.
a range of shades, right?
Yes, right.
Likewise, size. So each of them is a template which we should instantiate into multiple labeling functions. Because that's where we should provision for some slackness, right? The slackness of match. Does that
Right.
make sense? So
Yes.
when you say flipping, right? So um, maybe the flipping can be instead of just flipping, there could also be some perturbation, some rotations associated with the flip.
Right.
Is that
Right.
possible?
That is also possible. You are right. Because how they have cut that lymph node will be different, right? It will not give an exact. Yeah. If you look at this, yeah.
Exactly.
Yeah. So I have actually not thought how we will be able to exactly match. Is there a way to do it? Even if not an exact match, what would be an ideal, less in compute heavy way of doing it?
Mm-hmm.
Because here it's just one image, right? So I can say, okay, turn it a bit left and turn it a bit right, but there should be probably a more nuanced way of doing it, right, Professor Ganesh?
So if you look at our distill package within Decile, we have lots of data augmentation libraries actually. I'll send you the link. Just give me a second. So one of our aims to flame in distill itself is data augmentation. Let me send the link on the group. Do look at the data augmentation we do there.
Akshat, please do it. Yeah.
Yeah. I'm just putting it in the.
I didn't get what the data augmentation is for.
So the data augmentation. We are talking about augmenting the labeling functions, right? So if you have a flip,
Yeah,
then
right.
there are perturbations around the flip. There's some
But
potential
the labeling
rescaling.
functions are just to identify the RS cells initially, right?
The labeling functions are to help identify the RF cells with the ultimate goal of diagnosis, right? The consensus between the labeling functions will. You write labeling functions for a small subtask which form part of the signals to the model overall, right? You're not going to use a labeling function itself. The consensus across labeling functions is what will help you give the final diagnosis. Isn't that correct, Kshitij?
So actually, once we identify the Reed-Sternberger cells, the diagnosis is reached, right? But that is not the aim of this exercise also, right? We identify the labeling functions, we identify the Reed-Sternberger cells with the intent of deleting their information from the pink image on the right side. That is what we are trying to do.
Right. Right. That I understand. But it is towards the goal of identifying the Reed-Sternberg cell, right?
Sorry, I didn't get it. Sorry.
The goal is to help identify the Reed-Sternberg cell.
No, the goal of the labeling functions is to identify Reed-Sternberger cells. You are correct. But after that, once we identify the Reed-Sternberger cells in this light blue image that we have on the screen, right? We will identify the Reed-Sternberger cells. But after that, actually, we also want to identify the variations in the microenvironment around it, which comes not from this image, but the image on the right side, which is the pink image. So, but the problem is these two images are not exactly overlapping.
Correct.
So what we are trying to do is that we find the exact locations of Reed-Sternberger cells on the image 1, which is right now in front of our eyes, which is slightly magnified. We identify the Reed-Sternberger cells, we identify the location, and then we overlap this image with the HNE image, which is the pink image here, which will not be an exact overlap, it will be an approximate overlap, but it is still okay. We overlap it and we delete that Reed-Sternberger cells from the pink image.
Correct.
And once we do that, we do some unsupervised clustering to identify if there are different types of microenvironments. Because anything other than the Reed-Sternberger cell is considered a microenvironment around in the lymph node, right? And this microenvironment is actually associated potentially with the aggressiveness of the tumor. So what we have to identify is that once we do this, not so exact overlap, but we still do it, we delete the information of the Reed-Sternberger cells from the HNE images. We have 50 of them. To do an unsupervised clustering on these 50 images to see if there are different types of microenvironments. So that is the aim, right, Subhash?
Yeah. So Professor Ganesh, what Kshitij mentioned is actually that way we want. So one is identifying RSS for diagnosis, but the microenvironment, be it a lymphocyte rich, lymphocyte depleted, granulocytic, or macrophage, that also gives us information about the prognosis of the patient. So the depleted ones will be very bad, the rich ones will do good. So that information also we can get it like computational or mathematical. Okay, this is the microenvironment, and these are the subclasses. So this belongs to a lymphocyte rich or a depleted or whatever. So that will help us to give like a complete report or a complete information. Okay, there is an Hodgkin's lymphoma, and this is of this subclass. So this is how the patient may behave now. So that is the actually the aim which we want to reach. That is our ultimate goal.
Okay, so then I have something more to add here. So then, Dr. Kshitij, now I feel there are other components within Decile that can also be used. In fact, Akshit is quite familiar with targeted selection. So Akshit, maybe it's like deja vu. We have to can revisit what you did earlier also. My understanding is as follows. So you start with the labeling function, you build a consensus model. In fact, I think there are some new ML problems also we need to solve along the way. But let me begin with run-of-the-mill approach, Akshit. Right. So run-of-the-mill approach would be what you use. You design a bunch of labeling functions. I would still insist that you consider the augmentation techniques around the labeling functions, right? So that you're not just stereotyped, right? You look at some diversity. Akshit, can you keep acknowledging that you're getting what I'm saying?
Yes.
So one is that I stand by what I suggested earlier, data augmentation. I'll send you the link to Distill, which has incorporated several of the data augmentation techniques. But once we have, the road doesn't end with the Reed-Sternberger cells. Our goal is also to identify, diverse set Akshit, probably we can do targeted subset selection, right? So our goal then is identify a subset. In fact, say targeted subset using facility location, right? You know FLMI, right, Akshit?
Yes, yes, yes.
So suppose the labeling functions they become like if they can have targeted the output. A straight a run of the mill approach would be use the output of the consensus model from the labeling functions as a targeted set, right? And use that to actually identify subsets based on something like facility location, so that you get no representation. You could in fact consider a combination of facility location and set cover, or maybe even determinantal point process for diversities, right? So I think we can consider multiple options there.
You there,
Going
Akshit?
forward, yeah, Akshit, did you? Sorry.
Sir, not all of it. Basically, we want to use target. We have the output of the labeling functions model,
Yes.
where we have identified the RS cells. Then this would be the targeted selection subset, and then
Yes.
we'll use facility location for what exactly?
Facility location to identify the different possible microenvironments.
Oh,
So
okay.
different segments. So because we want the targeted subset is because the microenvironments must be around the reach state of the cells, right?
Yes, right.
Around what we get through a consensus model.
Yes, right.
But you want to go beyond the cells to also look at different microenvironments. And therefore, I'm saying we want combination. We want targeted, and we also want a larger subset to be selected. Not just selected, but kind of clustered as well. That's the keyword Kshitij was using.
Yes,
But
after we delete
what
it.
we,
Yeah.
right. But instead of doing it in a very ad hoc manner, if you could do targeted selection, then we have both. We maintain alignment with the Steinberger cell, right? The targeted set that we have, and also help create targeted clustering.
But the targeted clustering will be for only these Sternberger cells, right, Professor Ganesh? But that is
For the
not what we.
microenvironments, right?
Yeah.
We want to do.
We want
for
to
the
do it for micro.
microenvironment.
Yeah.
So
Yeah.
just
So
to identify
microenvironment. Yeah.
the Reed Steinberg cells, we'll just use data programming, right?
So this is again the strawman approach. The strawman is do data programming, identify Reed Steinberger cells, and then as a next step, the step 2 in the strawman, you are doing targeted subset selection to identify microenvironments, basically cluster the microenvironments
Yes, right.
around the
Got it.
Steinberger cells.
Yes.
That's still a strawman. I mean, I think a more principled ML approach is also we need to investigate here. So we don't have to stop at that. We can actually do ML innovation. Can the two be done in one step, right? Can we do data programming to identify a diverse subset of microenvironments in one shot? Did I make sense? Hello? Am I audible?
Yes.
So there are two. The first strawman was a two-step approach. The two steps you understood?
Yeah. Identifying the RS cells using data programming and then using that as a selected targeted subset.
Yes. I'll use that as a target to do subset selection of microenvironments.
Yeah, right.
Kshitij, that made sense, right?
Yeah, but what I don't understand, and this is probably the limits of my understanding here. So we use data programming to identify the Reed Sternberger cells here, right? So we have identified for let's consider this hypothetical situation where we have identified all the Reed Sternberger cells in this image that we have right now.
Right.
After
Right.
that, once we overlap this image with the image on the right side that we have. What happened?
Stop screen sharing.
Oh,
Yeah, please share the screen. Yeah. If we are able to overlap the Reed Sternberger cells information on the image on the right side and delete all those locations where we are confident about Reed-Sternberger cells, right? We take them off. So now we have an image, H&E image, which has only microenvironment information. So beyond this, what were you suggesting? I didn't understand.
Yeah, so the subtraction that you have to do. I mean, why are you trying to subtract?
Because we don't want those Reed-Sternberger cells information we only want microenvironment information. Yeah.
Yes. So in fact, then I'm thinking, the purpose behind, I think it's important to write down the intention clearly. So intention is subtraction, right, and not targeted.
Right.
So maybe
No.
privacy preserving subset selection is what we want. So what we want is, so we don't want just redundant information about the Reed-Sternberger cell, right, that you already encoded.
Yes.
Sans that you want to cluster the microenvironment.
Yes, correct.
So then actually we need not MI, but we need the privacy preserving, the conditional CG basically. We need something like FLCG. Akshit?
Yes, sir.
So instead of doing the subtraction explicitly, what I'm saying is, can we do an FLCG, facility location conditional gain? Because where you're trying to do privacy preserving clustering. We want clustering which is sans the Reed-Sternberger cells.
Right.
Yeah, right. But for that we okay, got it. Yeah. Yeah, okay. So we basically need data that is different from the RS cells. And the data that is similar to the RS cells we subtract, and we create clusters in the data that is different from the RS cells, right?
Yes.
Conditional gain.
Yes. Exactly. Does that make sense? No?
I understood.
Yeah, and ideally, if this is two stage, so instead of subtracting, Kshitij, what you're suggesting would have been 3 stages, right? Yours was saying, okay, first, the labeling function, get the RS cells, then subtract the RS cells, and then do clustering, right?
Right. 3
I've
steps.
short-circuited from 3 stages to 2 stages.
Perfect.
With my suggestion.
Right.
But I'm suggesting if we can make it 1 stage, that will be even better, right? It'll be a really nice ML contribution per se.
Right.
If we can come up with a new model which says, well, given the data programs, I really want to do targeted, or no, I want to do privacy preserving subset selection given the data program.
Yeah.
So I want to find clusters modulo the data program, not even the RSS, right?
Right. Yeah, this actually also helps Akshit because he wanted to work on something.
Yeah, right.
Yeah, right.
Yes.
Yeah,
Sounds good.
so it feeds into what you really wanted to also work towards, right, Professor?
Yeah, yes, Akshit, and please understand, I can tell you from my tons of successful deployments of ML, you have to get your hands dirty with the actual problem. It will give rise to very new avenues of research.
Yes, that is true, sir.
We should not simply try and cook up areas for the heck of it. There are enough that will come up by themselves. So I really enjoyed the discussion.
This is good. This is like this becomes a solid ML contribution in addition to solving the exact problem that we are trying to solve, right?
Right. Exactly.
Yeah. This is really nice. Okay, so could I, Professor Ganesh, could I just request Akshit to summarize this once for us and then also write it down and summarize it for us?
So yes, firstly, I made short notes. So firstly, we need to use it. There's a lot of noise.
Can't hear you. I can't hear you. Sorry.
Yes, there is some noise, I think. The noise.
Perfect. Thank
Yeah.
you.
Yeah. So basically, Yeah. So basically, we first need to write labeling functions to identify the read chain cells. So in those, we have three, broadly, we have three conditions: that the nucleus should be blue with a brown cytoplasm around it. The cell could be multinucleated, and the cells are usually bigger. So
Yes.
these are the three categories that we are using for the labeling functions to roughly identify the RS cells in the CD30 stain slide. After
Okay.
we have the RS cells, then we'll use data augmentation. Sorry, not data augmentation, but targeted subset selection, where RS cells are the target, and then we'll use FL to remove RS cells from the from the environment, and then do clustering in the microenvironment.
Right. Right. Could you also write it down? And also, what I'm going to do is I'm going to share a Word document in the
Yeah, okay,
description.
okay. I'll make a Word document and share it with you.
Yeah, could you make a Word document about what we have just? So basically, I would request you to do the following. Uh, b- Mention the problem statement, mention the potential solution that we are going to do in a very clear way. You can be verbose as you want, right? Uh,
Okay.
so it's not a problem. And put that Word document, a Google Doc document, in the description of the group.
Uh, which group?
The group, the TMH group that we have, the WhatsApp group.
Okay, okay, okay. Okay,
Okay.
oh, got it, got it, got it.
Okay. So that way, and
Can you repeat
please.
again? Mention the problem statement and
So firstly, don't try to be too concise. Okay. You can be as verbose as you want. Mention
okay,
the
okay,
problem statement
okay,
with today's date. Basically, what we are trying to do is we are trying to solve this specific problem by next week. Okay. So mention the
okay,
problem statement. So put the date, mention the problem statement in as extensiveness as possible, and also mention the solution that Professor Ganesh just suggested and that you understood also. Okay.
okay.
So that we know that you're working specifically towards this.
Got
Okay.
it, got it.
Okay. So this is good. This is good. This was very, very productive.
So I will not take the effort of summarizing everything. I'll just give you the links, which I had promised, right? So to that's okay, right?
Yeah, yeah,
That
sure.
that's okay. That's okay. And I think Akshit will require to do that kind of reading also to finally come up with the solution that we have discussed here.
Yeah, right.
Is it
Akshit,
okay, Subhash?
can, yeah, Akshit, you can identify RSLs in the HNE. I mean, if are you able to make it out
In the
Sorry.
CD30, right?
in the
Yes.
no no in the HNE in the HNE?
So HNE,
Oh,
actually,
sorry.
Subhash, we are not even trying to look at RS
Okay,
cells. Yeah, we are not even trying to look at RS cells. What we are trying to look at is identify the RS cells from the CD30 image, and then through
okay,
location overlap, we want to just take them off. That is what we want to do.
okay.
Okay.
So
So
because
we
in
are,
this I see a lot of RSLs, but if you're not looking at, so we are going via the CD30 route
yeah,
that way.
because the CD30 is more specific, right?
Yeah,
Yeah.
yeah, it is more specific. So this HNE has its morphological characteristics. CD30 has its stain characteristics.
Yeah.
That is the difference.
But we are basically looking at CD30 stain characteristics because they are more specific and there is no noise from the other cells around, right? Yeah.
Correct.
Yeah.
So even in this image, if you see now the HNE, there are a lot of large cells. So just
Yeah.
to look at them. So not here
Yeah,
exactly
right.
where the junction. Yeah, there are some here, and at the junction where that pink and blue starts. Like if you go out, zoom out, zoom out completely.
Okay.
Yeah, and the junction where the light pink and the dark pink starts now, because this darkness is because of the thickness of the section. Yeah, so here if you can see, there are cells which are quite large. Like you can zoom in, more zoom in. Yeah, all these cells. I mean, I can't make out on the image, but I think you at your level you can see it. There are a lot of large cells in these areas
Yeah,
compared to the
Subhash,
background. See,
actually,
it's here. Yeah,
the problem is,
one
Subhash,
which
it's
has
still,
clearing.
sorry, the problem is, Subhash, because you're so trained at it, right? It might look very easy for you, but it is not
No,
for
no,
us.
I'm just saying the cells which have a clearing around it. So go little right to your cursor,
So
little
the
right.
one that is the clearing around it, right? I see it. I see
Yes,
it.
yes, yes. Yeah, yeah. So this one and the one which is down
Yeah.
below that.
Yes.
All these are RSLs and lot of, so this area has a lot of RSLs. So if you see at you in on your laptop or PC, these cells have different characteristics, prominent nucleoli, and they're quite large. If I compare it with the adjacent microenvironment, you can make out that they are at least 3 to 4 times larger than the background.
Yeah,
Yeah, so
Yes,
Professor.
right.
RSL. Yes.
So
So these
Professor
are
Ganesh, we can
This
also
in itself is
include
a
this
cell,
also,
right?
right?
yeah.
Each dot is a cell, right?
It's not is a
Or is it
nucleus.
a nucleus?
Yeah, so the one which you're pointing now is either a lymphocyte or plasma cell. So this comes in the microenvironment. So
Oh, acha.
actually,
Okay.
if these are all microenvironment, the one which has a clearing around it, and
Yeah,
uske
yeah.
andar yeah. So this is an RSL which is sitting inside. And if
Yeah,
you
right.
come
Okay.
extremely left, say around 9 o'clock, 9 o'clock, I can't see a so little down the large cell, which so this is the little down one, little down. So this is also an RS cell, the one on the right, little right, एक cell right जाओ.
Okay,
This
this
one.
one.
No, the upper one,
Okay.
उसके ऊपर का.
Uh,
Yeah, नहीं, एक नीचे. Anyways, the one I'm trying to say is the one which are large are easily identifiable, and if you see the one which had clearing around, उसके अंदर also you can make out a small dot. That is a nucleolus.
Yeah, yeah. This
Yeah,
I
so
right.
understand.
This
Yeah.
small dot.
yes, see this. So this dot you will not see in any other cell. If you see in the background, there no cell is showing this nucleoli. And they're quite large. The
Okay.
cell characteristic, the size characteristics, and in this area there are many. Like if you see on your PC or laptop, you'll find out many of these large cells. Some may be even binucleate, like two nucleus sitting in one clear zone or one
Yeah.
cytoplasm. But what I'm saying that clear zone is not specific. Sometimes you may get it, sometimes you may not. It is all processing dependent. So we can't use that as a characteristic. But size characteristic is definite there.
Okay, so Professor
Okay.
Ganesh, we can also use this as a labeling function, right? To identify on HNE cells, because right now we were already restricting ourselves to CD30 stained in the first image that Akshit was showing. But here actually we can also do it on the HNE cell. This will be another labeling function, right?
So what exactly will be the labeling function? Can you just once
So,
summarize that?
but in a very heuristic way, it will be one large nucleus, and around which there is white clearing that the cytoplasm is not stained, so it
Actually,
is white in color. So if you
no, but
Akshit, you
it will
could move
not be
your
there.
yeah this
Yes.
one yeah. Can this by
Yeah,
itself
this
also
can
be
be. I think this can be.
right? Yeah. This can also be a labeling function.
Right.
It is, but this clearing will not be always there. That's okay. Is it
That's
okay?
okay because labeling functions need not be true for all instances. They can be true for some instances because other labeling functions will make other instances true. Did you understand what I tried to say?
Okay. Okay.
Yeah,
Yeah. Understood that.
yeah,
Yeah.
yeah.
Yeah. Yeah. Yeah. So Akshit can go through the slides, this section. There'll be a lot of similar cells in this
Yeah,
zone, in this area especially.
yeah. This is good. So you basically we discussed 3 or 4 labeling functions in the CD30, but we have another labeling function in this image as well. Now the question is how do we combine them because they are 2 different images. Professor Ganesh, any thoughts on this? Will it be a problem for the solution that you had suggested?
Um. So your question is, how can this labeling function be incorporated a white patch I'm just call
Yes.
it white patch labeling function.
Yeah, white patch labeling function. Yeah. True.
So how can this work in conjunction with our previous one?
Yeah, because the previous ones were from a different image altogether, right? So
Yeah, but that's where, see, we may do spot checks and inspections of the sort, but that's where ML, unsupervised learning is supposed to help, right? It's supposed to help consolidate across our different spot checks,
okay.
right? So these are selectively designed. That's what will happen. Labeling functions, you look at few and you design them. In fact,
Okay.
before you even deploy them, there's a very important principle. If you look at the Spear package for every labeling, we look at conflicts, coverage, and all. You must have seen, right?
Mhm.
For every labeling function on the unlabeled data, we should look at the amount of conflict between labeling functions, the coverage.
Mhm.
Yes, but once we do that, the unsupervised model is supposed to take care of it.
Okay, I understand. I understand. Okay.
Does that make sense?
Yes, yes, yes. So ultimately, the white patch labeling function can be a labeling function in itself. Yeah.
Right.
Right.
It should just be treat like another labeling function.
Yeah, it will
Now
be
you
just
could do the
another labeling
following.
function.
See, what we have probably not looked at so far is the fact that there could be priors associated with labeling functions. You may say one is more confident than the other.
Right, right, right. I understand. And that will also feed into the confidence of identifying all Reed-Sternberger cells. Yeah.
Right.
Okay, good. This is good. Akshit, you are understood. You have understood and you're on board, right, for this?
Yes, sir.
And this basically
I'll
gives you the
make the
problem.
doc.
Sorry?
I'll make the doc by tonight and share
Yeah,
it with you all.
put it. Yes, yes. Please do that and do it today itself because you will forget.
Yeah. That's why. I
Yeah,
have written down a few pointers. I'll
yeah.
elaborate on them.
So you are getting exactly what you wanted to work on, right? So that should make you really
Yes,
happy.
sir.
Yeah,
Yes, sir. This looks good.
yeah. Perfect, perfect. Thank you very much. Um, Subhash, you want to add anything more?
No, but I think next time when you visit TMH, I mean, Akshit can also visit and we can see under the microscope exactly how the cells look for
So
better
actually,
understanding.
yeah, my aim actually is that Akshit works on this this week, and actually next week I'm going to come to see uh, Dr. Hasmukh anyways. So we will
Yeah,
come. I'll coordinate with you also, and I'll
yes.
get Akshit along. Yeah,
Yeah,
I'll do that.
so we can see exactly what we are talking about under the microscope and what is our microenvironment and everything. And that
Right.
will give him a visual image like what exactly we want and what we
Yeah,
expect.
yeah.
Yeah,
But now I think Akshit has sufficient examples to work with,
yeah,
so it
yeah,
should be fine.
Yeah,
yes.
Yeah.
right.
Just that there are too many variations is the one. Every lymph node will have a different looking RS cell.
Yeah,
That
but
way.
actually, yeah, that I think once we have a large number of labeling functions, because also Akshit, this is
Yes.
an important point here, right? What Subhash just said, that every lymph node might have a different kind of looking of RS cell. So again, you might have to design more labeling functions. So you don't just stick to one lymph node image and make the entire consensus model, right?
Yeah, right.
Okay, perfect.
Yeah.
Okay,
Yeah. Sounds good. Yeah.
so Akshit, we expect some good progress by next week. Okay, I have also given the same ultimatum to. It's not an
Yes. I'll
ultimatum.
keep telling you. I'll keep
Yeah,
telling you as the progress goes on.
good. Okay, thank you. Thanks a lot. Thank you, Professor Ganesh. Actually,
Okay.
this was very nice.
Yes. I think today. So that looks like there are 4 directions, right? I mean, someone has to write. I'll send the recording as well. But I think you should talk about the existing 3-step process, right, which you had talked about earlier.
Yes.
Then the
Yeah.
2-step process I talked about.
Yeah.
Then a potential 1-step, which is in the future. And
Right.
then another direction you talked about was more labeling functions, right?
Yeah.
consensus amongst more labeling functions.
Yeah.
Okay.
Perfect.
Actually, will you summarize all of this? Is important because it's out of sight, out of
Yeah,
mind.
yeah, I'll write all of them down.
Yeah. And by today, Akshit, okay? Which would be nice.
Yeah, by today.
Okay. Thank you.
Okay.
Thanks a lot, Professor Ganesh. Thank you.
Thank you.
Bye.
Thanks. Okay, thank you.